Okay, today we're going to talk about factoring special cases. The first one I'm going to show you on this screen is probably the most important one to show you, and that is called difference of squares. And this is what it says. A squared minus b squared is equal to, and then this is the factored form of it, a minus b and a plus b. Now, that may look a little confusing, but when we start using it, it'll make a lot of sense. So what it's saying is if I have two things, say x squared and 4. Now these both have to be squares. X squared is clearly a square. 4 is a square because it's 2 times 2, and it has to have a minus between it. Now notice it says difference of squares, not sum of squares. This must be a minus. There is no rule for plus. As a matter of fact, if you tried plus, you'll find out they end up being imaginary anyways. So make sure this is a minus symbol. And what it says is, if I can rewrite it like this, I have to figure out what goes in here and here. So in here is just going to be x, because x squared is the same as x squared. But over here, this is going to be 2, because 2 squared is equal to 4. And you can do this obviously in your head, but that's what is important. And what it's saying is, whatever is here and whatever here is going to be in our answer. So it's going to look like this, once with a minus, once with a plus. It doesn't matter which is the plus and which is the minus, so you decide which one you want. As a matter of fact, I'm going to erase that and make that in black, because that's part of your structure. It's supposed to be black. There we go. So once with a minus, once with a plus, or plus and minus, it doesn't matter. And whatever is in red is going to be your a. So this a is going to end up being x, so it goes here. It also goes here, and it also goes here, so this is going to end up being here and here. And whatever is in the spot where b is goes here and here. In this case, it is 2, so it ends up being 2 and 2. So without having all the nice color, you would say that x squared minus 4 is the same as x minus 2 and x plus 2. And now this is the factored form. Now the reason that's important is if you remember from the solving, if I just simply make this equal to 0, in which case a lot of cases it will be, then we're going to just set each one of these to 0, and you're going to find that x is equal to 2 and x is equal to negative 2. And those are your two solutions. So that's what makes this really handy to see. So let's do another couple. So let's say I give you x squared minus 25. And I want to factor this thing. So the first thing I'm going to tell you is that we are looking for something squared minus something squared. And if we can find that, you're going to have two things multiplied, once with a plus, once with a minus. Notice I switched the order this time. That's just to illustrate it doesn't really matter. And then we're going to figure out, well, what is the squared here? In this case, it's just x. So that's going to end up going here and here. And then we're going to do the same thing with b. What squared is 25? Well, the answer is 5. So this is going to be a 5 and a 5. So our answer for how do you factor x squared minus 25 is x plus 5 and x minus 5. And if you wrote this as x minus 5 and x plus 5, you are also correct. Either one of these is correct. So if you were trying to solve it and this was equal to 0, you'd end up with 5 and negative 5. But what if this is a little bit more interesting looking? Well, let's take a look and see what that might be. So let's say instead I have 2x minus 50. Now my goal is to do the same thing. I want to have two things squared. But if I start trying to do this, I immediately have a problem because nothing squared equals 2. And to my best knowledge, I don't know of anything squared that's 50. Fortunately, these have something in common. So remember that video about things in common? That still applies here. So in this case, they have a 2 in common, so we're going to bring the 2 out front and then see what's left behind. So 2 times what is 2x? Well, 2 times x. Actually, this should have been a squared. My mistake. 2 times x squared is 2x squared. And 2 times what is 50? Well, this is going to be 25. So we got 2 times x squared is 2x squared, and 2 times 25 is 50. So I can reduce this, again, my apologies, it should have said x squared to begin with, is going to say this. Now, the 2 is outside, so it's just going to go for a ride, and it's going to end up being out here and it ends up coming out here. So we're going to ignore this 2 because it's just going to go along for the ride. We're only going to look at this middle part. So let's take a look at this middle part. I want to know what squared. Well, that's x. So this is going to be x and x. And then same thing with the 25. Well, what times itself is 25? Well, that's going to be 5. So these two are both 5 as well. So my final answer, the 2 went along for the ride. And then inside here, we get x minus 5 and x plus 5. Now, if I was solving it, say this was equal to 0, the 2 just kind of gets ignored because 2 can never equal 0, but I'm still going to end up with x could be 5 from this one, or in this case, x would equal negative 5. So there's my 2 solutions. So if you do have something else, you can use the things in common first, and that's a perfectly acceptable method to do. And let's say it's a little bit even more confusing. So let's say I have, we'll keep with the 2x squared. And let's say I do minus, I don't know, 30. And I'm going to say this is equal to 20. So again, first thing is I want this to equal to 0. It currently is not. So first thing I'm going to do is subtract 20 from both sides. So 20 minus 20 is 0. 30 minus negative 30 minus negative 20 is negative 50. And I still have this 2x squared. And now I can do the other thing I was just doing, which is I have a 2 in common. So I'm going to bring the 2 out front. And then I can use our new technique and factor this thing. And as I just showed you, this becomes x minus 5 and x plus 5, because x times x is x squared, and 5 times 5 is 25. And if you multiply this out, you'll find out it works. So this is another technique that you can use in this case. So let's take a look at the next one, which is called a perfect square trinomial. And what it's saying is if I have something squared and something else squared, and the middle term happens to be twice when I multiply those two bases together, then my answer is just going to look like this. Now these are sometimes a little bit hard to see, and of course you could always factor it the old-fashioned way, but it's handy to see what happens here. So let's say that I have we'll do x squared minus 8x plus 16. So I'm looking for something squared minus twice those same numbers plus something squared. Because if I can find this, my answer is simply those two things squared. So let's see if we can find a number that would represent it. So if I want x squared, this is going to have to be x. So if, and this is a big if, it's going to have to work out, this would also be x, because the a's are in the same spot here. So I decided a has to be x because it's the only thing that would make this true. And if this is true, it's also going to be here. And I'm going to do the same thing with the b. In order to make b true, this is going to have to be 4. Because 4 squared is equal to 16. And if this is 4, because this is also b, this would also have to be 4. Now we have to verify that this middle term right here is indeed 8x. So let's multiply it out and see if we get 8x. Negative 2 times x times 4. We got the x. 2 times 4. So we do indeed have negative 8x. So this is our solution. And then when we multiply it out, the a ended up being x, and the b ended up being 4. So our solution, simply written, is x minus 4 squared. Now, if this was one of those equal to 0 and we're solving it things, this is just going to be x is equal to 4. And we're going to end up with twice, but we don't write it twice. So we're going to just say x is equal to 4. And if you wanted to see it multiplied out, it would be this, x minus 4. And since I have it twice, it's another x minus 4. But in this case, x is equal to 4. In this case, x is also equal to 4. Again, we don't need to write the 4 twice. So our solution would just be x is equal to 4. Now, the only difference between these two is the plus and the minus. If this is a plus right here, it won't let me draw it up there. So if that is a plus right here, this is a plus. If this is a minus, then the minus is also over here. This second one is always positive. There's no exception. So it's right here will tell you if this is a plus, then this becomes a plus. If this was a minus, this becomes a minus. So what ends up happening if I have something else? Well, let's say that I end up having something like 2x squared plus 16x plus 32. Well, just like before, we can look for things in common. In this case, we have a 2 in common. So we're going to divide everything by 2. That's an 8. And then I can look at trying to do this. And in this case, you're going to end up with x, because x squared is here. And this is twice. When I multiply this, is going to be 4 and x, which ends up being that 8x. And this is going to be our 4 squared. So this would be the 2 from out here. And this is going to become x plus 4 squared. Now, I'm going to go back to the first one because I want to show you one more thing we can do with this one. And then it would also be true on the next one. Let's say that I have 4x squared minus 16y squared. Can I still apply this rule in this case? And the answer is yes, because I can still identify things that would follow through. So I'm looking for something squared and something else squared, and if I can find it, then those two things, once with a plus and once with a minus, would be my solution. So the question is, can I identify something that's squared that equals 4x squared? Well, the answer is 2x. 2 times 2 is 4. X times x is x squared. So 2x squared is equal to 4x squared. I can do the same thing over here. If I do 4 times 4, I get 16. And if I do y times y, I get y squared. So 4y quantity squared is equal to 16y squared. So then my answers would also go over here. 4y would be where that b is supposed to be. And in red, where the x is supposed to, or the a is supposed to be, I would put 2x. So in this case, even though it looks different, I'm doing the same technique, but my answer just looks more complex. This would be 2x plus 4y and 2x minus 4y. So it doesn't matter what this is. If you can find something that when you square it, you get to here, it's fine. Just make sure that this is also being squared. Just like this is also being squared. They both have to be squared. So when I go back to this one, the same thing would apply. If I could find something here that's squared, so maybe this was like a 4, this could end up being a 2x. So as long as something here can be squared and something here can be squared, and when I multiply those two things multiplied by 2, I get this term, this still works. So let's take a look at the third case, and the third case is with cubes. So I'm looking for cubes. They're easy to identify because they have the big 3 by them. So let's say that I have something like x cubed minus 8. Now, you're probably not that familiar with cubes, so let's go through a few cubes. 2 cubed, well, let's do 1 cubed. 1 cubed is 1 times 1 times 1, and that is 1. 1 times 1 times 1 is 1, not 3. 1 times 1 times 1 is 1. What about 2 cubed? That'd be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And 3 cubed would be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And then these start getting real big real quick. 4 cubed would be 4 times 4 times 4. 4 times 4 is 16. Times 4, 6 times 4 is 24. 64 is what that is. And then by the time you get up to 5 cubed, you get 5 times 5 times 5. 25 times 5 is 125, and I don't know any more of 5 without having to do the arithmetic myself. So these are some of your cubes. Probably 1, 8, 27, 64, and 125 is about the ones you would ever need to know. After that, you're probably grabbing a calculator. So this happens to be a cube, and what it says, we're going to use the same technique we were just using a minute ago, is that the way you factor this is you put a parenthesis here and a minus. It's a minus because this was a minus, and it says to put a minus there. And then I get another one, and I have a plus and then a minus. excuse me, a plus and then a plus. And I'm looking for what cubed minus what cubed, because whatever these numbers are going to go in these spots. And notice that this is a square and this is a square as well. So I'll go ahead and put the squares here. And now let's go change our color and let's figure out what this number is. So what number cubed, excuse me, yeah, these are cubed. What number cubed is supposed to be x cubed? Well, x cubed is equal to x cubed. So everywhere you see an a, you're going to put an x. So that means this is an x, this is an x, and there's an x here. And then I do the same thing with the b's. So what number cubed is going to be 8? Well, we just did it over here. This is going to be 2. So this is 2, and this is 2, and this is 2. And notice this is a times problem. It's out of order. So now we got a little cleanup to do. X minus 2, unlike terms, so we can't do much with it. Over here, x squared, we're going to just leave as x squared. But here, we don't ever say x times 2. We're going to reverse the order and say this is 2x. And over here, we can actually do this arithmetic. 2 times 2 is just 4. So this would be our final answer. And we're not going to do much more with it for Algebra 1. Save this concept for Algebra 2. But I just wanted you to see that you could do the same thing. Now, if this had been a plus instead of a minus, you do exactly the same steps. The only difference is the signs change. So if this had been a plus, this is a plus, this becomes a plus, and then this would become a minus. So I have to erase this one. So this would have been a minus right here. So then our final answer, instead of being x minus 2, would have been x plus 2, x squared minus 2x plus 4. This last number is always a plus. Okay? So this one was for sum, and this one was for difference. So technique's the same. When you do your practice problems, you can have this out. I fully expect you to use these. It won't let me circle them. Maybe if I go big enough. There we go. Okay, I expect you to use this. So you can use this technique. I just want you to, I'm going to give you some numbers and I want you to get to your answer. But you can use this as a cheat sheet. This one you should recognize, but I'll let you use it as a cheat sheet. If I'm giving you something like this, I expect this one to be memorized. This one is way too common, way too easy not to use. Memorize it. If I see 2 squares and a minus, automatically 2 sets of parentheses, 1 plus, 1 minus, figure out what the square roots are, plug them in, you're done. So this one I expect you to memorize. This one and this one, I'll let you use this as a cheat sheet. If you got questions, please ask me.